What you're about to see is groundbreaking. China's first manned dive beneath Arctic ice. A deep-sea feat. In one of Earth's harshest frontiers. Why should you care? Because this mission doesn't just break technical barriers. It opens new doors for climate science and deep ocean ecology. In this video, we'll explore three things: how they pulled it off, what they discovered under that ice, and why this dive could reshape how we study the poles and the planet. China's 15th Arctic Ocean scientific expedition will be remembered for a milestone that captured global attention: the country's first manned dive under Arctic ice. At the center of this achievement was the Jiaolong submersible, supported by its mothership Shenhai-1 and coordinated with the icebreaker Xuelong-2 and survey ship Jiaolong. This wasn't just another expedition. It was China's largest Arctic mission to date, involving 4 ships working in harmony across the Chukchi Plateau, the Canada Basin, and the Central Arctic Ocean. Operating a submersible in ice-covered waters introduces challenges that even seasoned ocean explorers tread cautiously around. Unlike open seas, the Arctic ice prevents direct surfacing, meaning the crew had to plan meticulously to guarantee safe return paths. The engineering team managed pressure resistance, sub-zero temperatures, and navigational uncertainties in one of Earth's most unforgiving environments. This technical mastery alone makes the dive historic. The synchronized operations between Xuelong-2 and Jiaolong allowed near-continuous observation of high-latitude waters, something rarely achieved before. With multiple ships ensuring redundancy and safety, the Jiaolong's crew had the assurance needed to push into this uncharted domain. The dive also demonstrated China's ability to integrate deep-sea technology into polar research, bridging 2 domains that until now were rarely combined in practice. Calling it a first is more than symbolic. It represents a leap in capability, the proof that China can not only send unmanned sensors under ice, but also safely place human scientists there. This expands what is possible for Arctic research and cements a new benchmark for global polar exploration. While the act of diving itself was remarkable, the scientific findings are what truly elevate this mission. Researchers reported dramatic spatial differences in benthic ecosystems, with organism density, biodiversity, and body size shifting sharply across distances of just tens to hundreds of kilometers. Such variability underscores how sensitive life is to environmental factors in the Arctic's abyssal zones. The mission employed multi-depth benthic imaging systems in the ice marginal zone. These advanced tools captured multi-layered snapshots of deep-sea life, enabling scientists to see changes across time and depth. This technology revealed patterns in marine snow, organic particles that drift downward, feeding life on the seafloor. Understanding how marine snow forms and accumulates under retreating sea ice is critical for tracking energy flow in Arctic food webs. Equally important were observations of subsurface chlorophyll maxima, regions where microscopic organisms thrive below the surface. These zones act as biological engines, and studying them in the Arctic setting helps explain how ecosystems adapt as sea ice thins and retreats. Data of this precision had never been collected on this scale under Arctic ice. The expedition also strengthened understanding of the atmosphere-ice-ocean system. Through coordinated 3-dimensional measurements, scientists linked surface ice drift and melting patterns with deeper hydrological and ecological changes. By tracking sea ice movement and sub-ice currents in quasi-real time, they documented dynamic shifts that static sampling could never capture. Why does this dive matter beyond headlines? Because the Arctic is not just a regional environment, it is a global climate regulator, and the data gathered here influences models of weather, ocean circulation, and sea level rise. Until now, under-ice deep waters were one of the most poorly understood parts of the system. By placing humans and instruments directly into that environment, China has provided the world with fresh observational power. One immediate impact is on climate modeling. Arctic warming is accelerating faster than global averages, and understanding the ice-ocean interface is crucial for predicting storms, currents, and long-term shifts. This dive delivers the empirical evidence that allows scientists worldwide to test and refine their models. Another reason this matters is ecosystem resilience. The benthic organisms recorded during this mission form the base of a food chain that extends all the way up to fish, seals, and whales. By learning how these communities respond to ice retreat and nutrient changes, we gain insights into the health of the broader polar biosphere. There's also a strategic and technological dimension. Only a handful of nations have attempted manned under-ice dives. Demonstrating this capability signals that China can sustain complex, multi-ship expeditions in one of the planet's harshest regions. This doesn't just benefit China's scientists, it raises the bar for what global research missions can achieve. Looking forward, this dive could be the precursor to long-term under-ice observatories, permanent monitoring stations, or future autonomous submersibles designed specifically for polar conditions. It paves the way for collaboration, since the Arctic cannot be studied by one nation alone. Ultimately, this achievement isn't just about today's data. It's about opening the Arctic frontier for science tomorrow. China's first manned dive beneath the Arctic ice isn't just a technical success. It's a turning point in how we explore one of Earth's most fragile frontiers. By combining advanced submersible engineering with synchronized polar expeditions, scientists have opened a new window into ecosystems and climate processes that were almost invisible until now. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Thank you for watching, and see you next time.